Have you ever gone on a run and then just felt fantastic? Or maybe trained for a marathon and then thought you could do anything, take on the world? Well, not me. I've never been all that coordinated. It's kind of a defining feature ever since I was a kid. Something terrible happened after this picture was taken. Let's just say I should have been looking in front of me. So, given my checkered history with activity and fitness more broadly, my interest in this area came in a pretty roundabout way. I study psychotic disorders like schizophrenia, a devastating and chronic condition, and one, after 2 decades of research in this area, I have come to discover will be something that continues to inspire and to surprise me. For example, when I first learned in college that up to 1% of the world's population has schizophrenia, I remember looking around a room of about 300 other students and finding it almost impossible to fathom that as many as 3 would be affected. Another thing that really surprised me is that this is a disorder that impacts young people, typically in their early 20s. And when I began my first job out of college, which was working with people who just recently received the diagnosis, I really internalized what this meant. You see, schizophrenia involves the emergence of symptoms that can frighten and distract, sap motivation, make it difficult to think, and blunt the feelings of emotion right at a time when most young adults are typically taking their first steps towards independence. I saw this devastate dreams to start school, finish programs, begin a career, get more serious about a relationship. Another thing I found surprising was the status quo approach to treatment. In particular, a strategy of addressing symptoms after the disease has already begun just didn't seem at all effective. This is like treating something like heart disease after a heart attack instead of monitoring it early and intervening before the damage is done. This last insight led me to graduate school, where I immersed myself in a program that was designed to reimagine schizophrenia as something with roots stretching back earlier into adolescent development. But how do you study something like schizophrenia years before it happens? Well, let me explain. These figures are from an artist named Louis Wayne, who may have developed schizophrenia and continued to paint throughout his lifetime. And they're useful for describing something called the psychosis risk period, beginning with the cats on the left and continuing to the transition and onset of schizophrenia symbolized by the cats on the right. Now, we've all heard a sound in our house and been frightened before, particularly late at night or when we're alone. But after a minute, we usually realize it's the sound of a settling old house or our imagination, and we forget about it. But imagine a teen who's been having this experience more frequent, and that they don't dismiss it as imagination quite so easily. This would be considered the start of the psychosis risk period. And as it continues and progresses, this teen in question might develop new symptoms. For example, they might become visibly distressed if they see furniture in their room has been moved around a little bit. And instead of settling on the likelihood that a parent was taking a messy room into their own hands and cleaning up a little bit, give serious weight to the possibility that strangers were in there hiding cameras. Now, up to 3 in 10 people experiencing these kinds of symptoms will go on to develop a disorder like schizophrenia. And if that happened to the teen in our example, we might expect that they would hear intrusive voices warning them of danger, and that they might stop going to school or seeing friends altogether for fear that a secret organization was following them. The ability to define people in the psychosis risk period systematically was a seismic innovation, because for the first time, we were able to study this disease as it was unfolding, and most critically, for the first time, we had a chance to try and stop it before the damage was done. Now, after I finished this training, I began my own laboratory in Boulder, Colorado. And let me tell you, this was a place that was famous for all manner of physical activity. You would be out doing errands, and the Olympic team would just cycle by. And this would happen all the time. It was inspiring to many, but what I was figuring out was that one perk of being a scientist is that if you stay inside all of the time, people just assume you're a little nerdy, and they never guess that you're avoiding exercise altogether. Now, in my work in Boulder, I was following high-risk teens over time, and in the context of this research, I saw some go on to develop schizophrenia. And each time, I ask myself, why? And this is the kind of question that requires careful consideration of the brain, something that really changes a lot during the very same adolescent high-risk period. Let me explain. Assume that to become an adult, your job is to build a house, your brain. Now, we all come into the world with the foundation for the same kinds of common rooms, such as somewhere to eat or sleep or put your feet up. And these rooms represent brain structures, or more accurately, networks of brain structures. Each one is responsible for governing something, ranging from thoughts to feelings to actions. Now, each one of these rooms is composed of specialized cells called neurons, and they serve as conduits for information. We are born with billions of them, and then, during our earliest years, the appendages dramatically branch out, butting up against other neurons and forming trillions of junction points. As a result of this improved communication, we progress in our ability to perceive and interact with the world as we develop. So these are the materials for the house that we must build. But why so many? Well, it turns out humans are pretty unique in that we're born nowhere completely close to finished. Instead, we wait to see what our world is like before we fine-tune our rooms and make our houses. But we can't return to the convenience store in this example. And so what we do instead is we proliferate an abundance of this material early, throwing up scaffolding all over the house. Every possible corner you can imagine is covered with it in the off chance that a given project catches our interest. Then, during childhood, as our environment, our personality, and our circumstances lead us to experience certain things often, underlying neuronal connections that are activated during these experiences will strengthen. Let's focus in on the bathroom for an example. Let's say that you love taking long baths. Well, as a result, you're going to start building up a dream tub, but at the same time, you might spend less time in the shower. And the scaffolding for that is going to be neglected, growing cobwebs and gathering dust. So by the end of childhood, what's happening is all of the rooms are starting to take a lot of character, but the house is still a huge mess because half-finished projects are lying around everywhere. So adolescence then is the big cleanup period. We shed all of the immature neurons, and as a result, we're left with strong and efficient connections. We go from a childhood strategy of muffled shouting between rooms to benefiting from refined hallways and an intercom system capable of reaching the farthest corners of the house with ease and clarity. So the end result of this whole process is a house that is tailor-made on the life that you have lived for the one that you will live, an adult brain. But what then about the brains of the high-risk teens? Well, in our research, what I was finding again and again was that there was one room in particular that was in trouble. The hippocampus, named for the Greek word for the seahorse it resembles, is a tiny structure on both sides of your brain deep under the surrounding cortical layer. And for such a tiny structure, it has some remarkable superpowers. And we'll get to those in a minute. Now, at this time, I had moved my laboratory to Chicago at Northwestern University. And I was discovering that this was another very active place, this time full of sports fanatics. But like Boulder, I was finding loopholes to get out of exercise. And here, I had great excuses for large portions of the year. Besides, I could tell that in my lab we were really onto something. In my studies of the brain, the hippocampus in healthy teenagers looked just as what you might expect. But when we looked at the high-risk teens, we saw a hippocampal structure that was misshapen and smaller. And notably, it fell halfway between what we saw in healthy peers and in people who had already developed schizophrenia. The emerging picture here was a house where the building mechanics were off balance. The foundation and initial buildup was weakened to begin with, and then instead of helping with strength and efficiency, adolescents seemed to make things worse. Through no fault of their own, these teens were shedding neuronal connections that they couldn't afford to lose. And if such an important room was in trouble, well, the types of emerging symptoms we saw really gave us a hint about what that might mean for the whole house. Now, I had mentioned some hippocampal superpowers, and the first one is something called spatial memory. This is the ability to plan directions, to remember where you left something, or recall where something happened. It's something we rely on every day, and in our studies, we found that a smaller area of the hippocampus, called the dentate gyrus, was linked to deficits in this critical function. So just pause for a minute and imagine what that might be like, having an emerging deficit in this ability right at a time where most teens are learning how to drive. Well, where I grew up in Los Angeles, getting around on the freeway was a harrowing rite of passage. And you needed an iron nerve, and without a good sense of direction, bolstering that, it was really easy to get lost or even hurt. Or, for another example, imagine what it might be like if your favorite navigational app suddenly became less reliable, because each time you entered a new destination, little bits of old directions would pop up and commingle with the new ones. Well, these are just a few of the types of growing challenges that high-risk teens need to face. But what could we do about all of this? Well, that leads me to the hippocampal ultra-superpower. The hippocampus is one of the only rooms in the entire brain where you don't have to rely on the neurons that you're born with. In this cross-section of a rodent hippocampus, the fluorescent green stain represents entirely new cells. In a process aptly named neurogenesis, the hippocampus creates new materials throughout our lives. And this helps our houses avoid becoming dilapidated or falling hopelessly out of decor. We should be very grateful for this. In my case, I don't think I would be married today if my wife had seen how I decorated my 6th grade room. So, hippocampus helps with a lifetime of adaptability and learning. Hippocampal neurogenesis is critical, and in considering that and thinking about the data from the high-risk teens, I began to wonder, is there something we can do to dial this up a notch? And this is the question that led me to face my old nemesis, exercise. Because right at the same time as I was coming up with my conclusions about the hippocampus, research was coming out, first in rodents, and then in primates, and then in humans, suggesting that exercise actually increases the rate of hippocampal neurogenesis. So this whole time, I had my nose in a book, trying to figure out a way to battle the emergence of psychosis. And at the same time, I was studiously avoiding exercise. Now I had to face the possibility that exercise might be central to the very thing I was trying to do. But before I could really accept that, I needed to see with my own eyes that exercise and activity was linked to vulnerability in the high-risk teens I was studying. The problem is that's easier said than done. For one thing, being able to accurately count the level of activity in teenagers, given the huge variety of things they do every day or don't do, is no small feat. So here we call in a secret weapon called actigraphy. This is a highly sensitive device that picks up on the most minute instances of movement. And in my study, high-risk teens and healthy teens wore this on a wristband for about a week. Think like Fitbit on steroids. And what we found was that compared to the healthy teens, the high-risk youth were not engaging in the type of activity necessary to generate hippocampal neurogenesis. Instead, we saw a lot of sedentary activity, and that was linked to smaller brain volumes in this group. Now, I want to be really clear. Schizophrenia is complicated, and it's likely that a variety of factors are necessary to cause it. Sedentary behavior alone wouldn't be able to do it. But what the study did show us was that there was a potential link between the brain and activity that we might be able to exploit. What was needed was a clinical trial to see if we could use an experiment to test this possibility. But instead of drugs, we were going to prescribe exercise. So together with some very talented collaborators in Boulder and at Northwestern, my team recruited and enrolled high-risk teens in a study designed to examine the effects of 3 months of exercise on the progression of early psychosis in the high-risk teens. And the first thing we were thinking about was feasibility. How do you get anyone to do anything difficult, let alone teenagers, and have them come into the lab, get hooked up to our machines, and exercise fairly hard 2 to 3 times a week for 3 months? Well, I came up with the secret. I figured it out, and I'm happy to share it with you today. You have to promise them an iPad. Seriously, it really works. But the thing is that this is really just a gateway incentive. What we found is that exercise and all the things that come with it are what keep them in. For example, in the process of preparing for this study, we did an experiment where we found that high-risk teens were reporting that one of the big barriers to being fit was low self-esteem. And in this study, we found that exercising improved self-efficacy, therefore removing a barrier and allowing for more exercise. The teens liked coming in and exercising. Most finished the trial, and very few missed a single session. They continued exercising long after they got their iPad. Another thing, we were worried a little bit about the possibility of sedentary behavior getting in the way of us being able to maximally stimulate the possibility of neurogenesis in 3 months. And so we enrolled the help of an exercise physiologist who supervised each session to keep the teens on track. They also helped us to avoid the possibility that someone might cheat by walking. And to be fair, that's probably what I would have done. But we saw the farthest thing from it. One of the moments in this entire process where I realized this could really work was when I saw the data from one of our more difficult interval training conditions. I was inspired, really inspired, when I saw that high-risk teens who before this were sitting on the couch and playing video games and watching TV, were breaking their habits and coming out of their comfort zone and coming into the lab to exercise. And compared to controls who weren't exercising, they were getting fit. Another thing, we saw really good evidence of hippocampal engagement. After the trial, we observed that high-risk teens showed increased activity, improved communication between the hippocampus and an area of the brain responsible for governing vision, the occipital cortex. And in one of our recently completed trials, we saw an increase in volume in an area called the subiculum, which is one of the chief outputs between the hippocampus and the rest of the brain. Most critically, we saw in high-risk teens a significant decline in symptoms after the exercise trial. This is all the more exciting because exercise can be done anywhere. It's free, and it doesn't have side effects. With all of that said, I want to be clear that replication is needed. And in addition to that, it's important to remember that there are many roads to schizophrenia, and this intervention is intended to address only one of those roads. Now, we're not all at risk for schizophrenia, but the evidence is in, and it suggests that exercise can help all of us. For one thing, it impacts numerous brain systems implicated in prevalent diseases like dementia, anxiety, and depression. In addition to that, a growing body of work suggests a variety of activities can help with longevity, brain health, and a happy future. So, go. And this is me saying this. Go and be active. And if this work has made a believer out of me, and I can brave it, believe me, then you can too. Thank you.